Hey guys, welcome to lesson 12.7, Theoretical and Experimental Probability. This is your penultimate lesson in Algebra 1. There are two different kinds of probability that we're going to deal with. Our objective for the day is to be able to find these two kinds, the experimental and theoretical probabilities. So, problem number 1, finding theoretical probabilities. So these are a couple definitions we need to take a look at. First off, we have the outcome, which is the result of a single trial. We have our sample space, which is all of the possible outcomes, anything that could possibly happen. The event is any outcome or group of outcomes. And the probability is how likely is it that that event will occur. So to find the theoretical probability of an event, we take the number of favorable outcomes, i.e. the ones that we want, over the number of possible outcomes, how many there are. All right, so our first question, we have you are selecting one of the 8 planets in our solar system to write a report about at random, and we want to know what is the theoretical probability that you choose Mars. Now, how many possible planets are there? There's 8. And we want to know what is the probability that we will get Mars. So that is one possible outcome that we are looking for. All right, so 1 divided by 8 is 0.2125. Or 12.5%. Okay. Next up, we've got the planets in order of distance from the Sun are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And we want to know what is the probability that you will select a planet whose distance from the Sun is greater than or equal to Mars. So we are going from Mars over. Again, there are 8 total planets. And we want to know how many possible fall into that category. There are 5 of them. 5 divided by 8 is 0.625 or 62.5%. We won't be picky about what you write it as. All right. Lastly, Christy is playing a game. She's playing the game of life and spins the game spinner below. What is the probability that she spins less than a 4? So we've got a 1, 2, or a 3 satisfy that condition. There's 3 of them. There are a total of 10 spaces on the board. 3 divided by 10 is 0.3 or 30%. All right, problem number 2, finding the probability of the complement of an event. So the complement of an event is all the outcomes in the sample space that are not what we are looking for. So the sum of the probability of an event and its complement is going to be 1. Or 100%. That would account for every possible option. So we have a final exam containing 15 multiple choice questions, 10 true false, 10 short answer, and 5 essays. If I choose a question at random to review, what is the probability it is not multiple choice? So our total number of questions, we add those up, 15 plus 10 plus 10 plus 5, and that's going to be 40. And we want to know what is the probability it is not multiple choice. So we're going to add up all the ones that are not multiple choice. So 10 plus 10 plus 5 is 25. Do the math on that, and that's going to give you so you could take your total of 40 questions, subtract the 15 multiple choice, and you got the 25. All right, and that's going to give us 0.625, which is 62.5%. Pretty straightforward. All right. Problem number 3 is finding odds. And odds describe the likelihood of an event as a ratio comparing the number of favorable and unfavorable outcomes. So we want to know what are we've got odds in favor. It is the number of favorable outcomes over unfavorable. The odds against is unfavorable over favorable. Make sure you pay attention to that. Yeah, we know you don't want to, but you have to memorize. All right, so what are the odds the spinner lands on a number less than 3? So we're looking for odds in favor. Our numbers less than 3 are 1 and 2, so that's 2 possible outcomes that are favorable. Numbers that are unfavorable would be 1, 2, 3, 4, 5, and 6. So we've got 6 outcomes that are unfavorable, 2 that are favorable. We write that as 1 over 3 or 1:3. Okay. All right. Letter B, what are the odds against the spinner landing on a number greater than 5? So our unfavorables are the ones that are not greater than 5. So that would be 1, 2, 3, 4, 5 possibilities that are unfavorable over the 3 possibilities that are favorable. Okay. Now, where do we see these kind of things in the real world? Let's be honest, gambling is the most common place you're going to see odds in the real world. That below there is the adult spinner wheel, which is called a roulette wheel. You'll also see them in all kinds of casino games. Odds are...
Oh, what about this?
Ah, yes. Wheel of Fortune would also be a great place where you're going to see odds showing up. What is the odds?
It's America's game.
Yep. What are the odds that you're going to land on bankrupt? So should you keep spinning? Okay. Now, problem number 4 is finding experimental probability. And this is based on data collected from repeated trials. So this isn't just theoretical, the perfect world, what is our probability? This is actually doing a bunch of experiments and seeing what your probability is. And so the way we do this is we take the number of times that that event occurs divided by the number of trials that you did. So a skateboard manufacturer inspects 2,500 skateboards. There are 2,450 that have no defects. We want to know what is the probability that a skateboard selected at random has no defects. We're going to write it as a percent as our directions say. So 2,450 skateboards are the ones that are no defect. The total trials is 2,500. Do the division and write as a percent, and that is 98%. So 98% of the skateboards this manufacturer makes are perfect. They are good. All right. Letter B, we have a survey on favorite pets. 28 people choose dogs. Yay. 15 choose cats.
Yay.
Boo. 4 chose birds. And 3 chose fish. Probably kids.
Hoover.
If a participant is selected at random, what is the probability that they prefer dogs as a pet?
Grr.
So we've got 28 dogs on top. And the total number of pets, we've got 28 plus 15 plus 4 plus 3, which comes out to 50. 28 over 50 is 56%. There's a 56% chance you will select someone who prefers dogs.
Grr.
Okay. Problem 5, using experimental probability. This is actually the real-world application of probabilities. So a manufacturer is inspecting 700 light bulbs and finds that 692 of them work. They have about 35,400 light bulbs in their warehouse. How many of those bulbs are likely to work? So first off, we need to find what is the percentage that are working. So you do 692 divided by the 700 that you tested. That gives us the percent that work. Now we multiply that by however many total light bulbs they have in their warehouse. So when you multiply it all together, you get approximately 34,995 of the light bulbs are going to work. All right, so this is, yeah. All right. Letter B, a quality control worker samples 500 LCD monitors and finds a cosmetic defect in 3 of them. If the company manufactures a run of 12,000 monitors, how many of them would you expect to have a cosmetic defect? So you find out what percentage of them were defective. 3 divided by 500, that'll give you the percentage. You multiply that by the 12,000 in the production run, and you're going to get approximately 72 of the monitors are going to be defective. So this is the real world application. Companies, any kind of manufacturer is going to do this all the time. They will select randomly a number of their product, and if it's too high of a percentage that's defective, they will shut down their production line and figure out what is their problem. So this is a way that you can make sure that your company is providing a quality product. All right, that's all for today's notes. We will see you in class.